connected. So let me bring this question here. So the question was this. We have three parallel plate capacitor. So we have a three parallel plate capacitor. This charge, so this is charge Q. This is charge minus 4Q. And what was the other charge? The other charge was 2Q. Okay. So the other charge was 2. This was 2Q. So the question was, what will be the final distribution of the charges on each side of the plates? Right, Tariq?
Yes.
Yeah, so Chavez, we were not there in the previous classes, so please go to the video lecture and then you will find that how do we solve this. So for the parallel plate capacitor, this is known that the electric field inside this plate would be how much? Chavez, Tarif? Yeah, electric field inside. Yeah, electric field at this point would be how much? Yeah, so your voice is breaking somehow. Yeah, so that would be 0, right? At this P point, total electric field in this direction would be equal to total field in this direction. So let's say that I suppose that on this side, the charge is X. Right. So on this side, charge is X. So what would be the charge on this side? Tarif. The charge on this, yeah, the charge on this side would be? Yeah. Yeah, what do you say? Faiza, can you remember? So what would be the charge? If this is a charge on this side is X, so what would be the charge on this side? Positive? No. So I am asking that how much would be the charge? So Chavez, can you tell me? Guys, see that, yeah, charge on this side is X. Q minus X or plus X, Faiza? So in this side, we have X, conservation of charge. Right, conservation of charge. So total charge should be how much? Q. Yeah, minus. Now, yes, good, Faiza. So that is the right answer. So you guys see that in this side, the charge is X. So let's say in this side charge is, let's say Q, Q dash. So Q dash plus X is how much? Total charge is Q. Right. So Q dash would be Q minus X. So in this side charge would be Q minus X. Right. Now calculate the electric field at this point. So electric field at this point due to this charge would be in this direction. Okay. And then electric field due to this charge would be in this direction. Right. And same case for these ones also. So the total electric field at EP would be how much? Let's say that due to this charge, this is in this side. Right. And due to this charge, this is in this side. So EX plus E, this is EX and this is E2Q would be equal to E minus 4Q and plus of EQ minus X. So who left? Again, Faiza got disconnected. Okay, so this would be how much? This would be sigma x by 2 epsilon naught, and this would be 2q sigma 2q by 2 epsilon naught. This is sigma minus 4q by 2 epsilon naught, and this is sigma q minus x by 2 epsilon. Right, so if we calculate, so this would be, this charge is x, so x by area. Similarly, charge is 2q, so 2q by area. In here, charge is minus 4q, but we skip the sign. We don't consider the sign because we have considered the direction due to this minus 4q charge. So polarity is then neglected. So this would be 4q and divided by a e 2 e epsilon naught. And due to this q minus x, so this would be q minus x by a 2 e epsilon. So this cancels, this cancels, this cancels, and this cancels. So we will have what? So this is x, and this comes over here. So this is 2x equal to 4q plus q minus 2q. So 2x would be 5q minus 2q, so 3q. So x would be 3q by 2. So the charges on this side, the charge on this side would be, yeah. So the charge on this side would be, let me write it. So this is 3q by 2, right? And this is q minus, so q minus 3q by 2 is how much? 2q minus 3q by 2, so minus q by 2. So this would be minus q by 2. And Tariq, you tell me that these parallel plate are facing each other. So if this is 3q by 2, so this would be what?
Minus 3q.
Minus 3, yes, yes, very good, very good. So you remember, if this is x, this becomes minus x, right? Yeah, so
Sir, how,
you,
sir?
yes,
How, sir?
yes, yes, yeah, because the electric field inside this region should be 0, right? Because these plates are facing each other, so electric field would be 0. Understood?
Yes, sir.
Yeah, because this is inside region, so this in this place the electric field will be 0. Okay, and if this is minus 3q by 2 and the total charge is minus 4q, so in here what would be the charge? Minus 4q is the total charge, and this charge is minus 3q by 2. So let's say this is q prime. So q prime would be minus 4q, and this is minus, so plus 3q by 2. So this becomes minus 8q plus 3q by 2. So minus 5q by 2. So this is minus 5q by 2. Minus 5q by 2. And if this is minus 5q by 2, so this would be what? Chavez, you tell me. Yes.
Yes, 5q by 2.
Plus 5. Absolutely right. Good. So plus 5q by 2. Okay. And now we can calculate the charge on this side. So the total charge is 2q. So 2q minus 5q by 2. So that would be how much? 2q minus 5q by 2.
Minus
So
1 by 2.
minus q by 2. Right. So minus q by 2. Is that clear, guys? So this was the question. These were the 4 plates, and we needed to calculate the charge distribution on each of the sides. So the final distribution would be what? If I draw this here, so the final distribution would be so this is minus, so this is minus, and you already know about the magnitude. And this is plus, so this is plus. This is minus. And this is what? This is also minus. And this is plus. And this is minus. So this is the final representation of the charge distribution. So any doubt in this question, guys? Yes, any doubt? Okay, so you guys please note it down. You guys please note it down. So we just have to use that at this point, the electric field would be 0. Yes, Faiza, understood. Okay, so yeah, please note it down, guys. And whenever you guys need me to scroll down the screen, so you guys tell me. So remember that these were the initial charges. These were the initial charges, and the final charge distribution is this. So whenever you guys need me to scroll down the screen, you guys tell me.
Scroll down.
Yes, Tarif and Feza, done.
Yes, sir.
So we needed to only find one charge, and then finding the rest of the charges is easy. Yes, done.
Yes, sir.
Okay, so you guys, please this time try this question. So I'm again giving you one question, so you guys try that. Let's say this is a Q, simple same question. So 4Q and minus Q. I can add one more plate, but let's keep it up to here. So you guys, please note down this question, and please send me the answer. Okay, so that we can discuss that if you guys understood or not. So yeah, this is the question. Did you guys take the screenshot?
Yes, sir.
Yeah. Okay, so in the previous class, we were doing this electric field due to solid sphere, right? A solid sphere has what kind of charge distribution? Volumetric charge distribution, right? So the volumetric charge density is charge by volume, right? So then we calculated the electric field inside of this solid sphere. Okay. And we found out that the electric field inside is rho r by 3 epsilon naught, or we can write it as kqr by rq, right? So up to this point, we did, right, Tarif and Faiza? Yeah, and now let us calculate the electric field. So what do we know? That we have a sphere. We have a sphere, and it's a solid sphere, right? Not an empty shell. So this is not a shell or hollow sphere. This is a solid sphere whose its radius is r. Okay, and we are calculating the electric field inside. So this came out to be, let's say this distance is r. So the electric field inside came out to be rho r by 3 epsilon naught. So this is the direction of r, right? Or we can write this in this manner, that this is kqr by what was that? RQ, 4 pi RQ, or what was that? So this was kqr by RQ. kqr by RQ. Okay. So, and this is again in the direction of r. So this was E inside. Let us remember that. And you see that this magnitude varies as this magnitude varies as r, directly proportional to r. Now let us calculate the electric field outside of this sphere. So we have this sphere, okay? And its radius is r. So we want to make the Gaussian surface. So it will be inside the sphere or outside the sphere?
Outside.
Yeah, outside, right? So let's say that this is the Gaussian surface that we made, and this is a sphere. So the Gaussian surface would also be a sphere, right? because the criteria of Gaussian surface is that we want to simplify this integral. We want to simplify this integral. So this has some dot product and this has this EDS also. So in a Gaussian surface, there are two peculiar properties, right? First is always understood that it is a closed surface. Then we make the Gaussian surface like that way only, where the ds area vector direction and the electric field directions are either parallel or perpendicular, right? So that this EDS becomes simply EDS, right? And when they are parallel, or if that is perpendicular, so then this would be zero. And the third case that this E is uniform, so E is taken outside. So these are the property of the Gaussian surface. Okay, so this is already done in your class. Yeah. So this distance is how much? R. Right. So applying Gauss law. Your E dot ds, this is S, would be Q enclosed by epsilon. Right, guys? So we see that this is a whole Gaussian surface. So the Gaussian surface is up to this point. The Gaussian surface is up to this point. But the charges are only in what surfaces? In what space? So the charges are only
Solid.
distributed. Yeah, so only distributed at this point. Right. So let's say that total charge is Q. Right. So Q enclosed would be how much? This would be simply Q. Right, guys? Is that clear, guys?
Yes, sir.
Yeah, this would be epsilon. And I have made the Gaussian surface in such a way that all these properties are fulfilled. So this would be simply E of S ds. So the surface area of a sphere is how much? Yes, surface area of a sphere. 4 pi r square, right? Which, yeah. So this would be Q by epsilon naught. So E would be simply Q by 4 pi epsilon naught r square, just like the point charge, right? So this is E outside. So my E outside is KQ by R square, just like the point charge. Is that clear, guys?
Yes, sir.
Yeah, so you guys quickly note down from here. Okay. Just remember this thing, because this will come in handy. So just remember this thing. This thing is important. Yes, noted, everybody. Okay, Faiza has noted. What about you guys?
Yes, sir.
Yes, sir.
Okay, so you see that in the case of a solid sphere, so E inside is how much? E inside varies as KQR by R square. Or was that square or cube? So that is Q. This is Q. And E outside varies as KQ by R square. Right. So at the surface, at this surface, so at R equals to R, my E surface would be how much? This would be simply KQ by R square. Right, guys?
Yes,
Is
sir.
that yeah? So now we will plot the variation of the electric field. So the variation of the electric field of this solid sphere would be, let's say this is R, this is E, okay, and this is the boundary, this is the surface. So you see that firstly, E inside varies as R, right? So it is directly proportional. E y equals to x is which graph? Yes, if you plot y equals to x, so that
Straight line.
would be straight line, right? Passing through the origin. So this is 45. So E directly proportional to R. So straight line, right? Up to this point, where this EA at the surface is how much? KQ by R square, right? And after this, E varies as 1 over R square. Right. So 1 over R square is hyperbolic. So this will follow this kind of variation. So this is E directly proportional to 1 over R square. This is E directly proportional to R. So is this graph clear to you guys?
Yes, sir.
Yeah. So please note it down, and then I will talk about the next topic. So in today's, I will quickly talk about cavities, and then yeah, cavity is the last topic. Yes, whenever you guys note it down, please tell me so that we can move ahead.
Can you explain the once again?
Yeah. What did you say, Tarif? Can I explain once again?
Sir, can you explain the graph once again? Yes.
Okay. So you see that at the surface, right? At the surface, and then you have this inside. So this is inside, and this is outside. Correct, Tarif?
Yes, sir.
So in the inside, the electric field varies. So this is directly proportional to R, because K, Q, R, Q, these three quantities are constant. So E is directly proportional to R. So let's say if E is 1, so this would be 1. If E is 2, so this would be 2. Right? So this will follow a straight line. Up to what? Up to this point. So this is the boundary. This is the surface of this sphere. So is this graph clear to you, Tariq?
So yes.
Yeah. And after this, you have the outside of this solid sphere, right? So outside the solid sphere, the E varies as 1 over r square. Right. So from starting from here, E goes as 1 over r square. Right. So what is the graph of 1 over r square? So let's say that let's say at this point. So let's say at this point, this is a 3 point. So let's say at 4. At 4, your E would be how much? 1 over 4 square. So that would be 1 by 16. So that would be, let's say, at here. Okay. And let's say at 5. So at 5, this would be 1 by 5 square. So this is 1 by 25. So this is also small. So the graph will vary as this. Is that clear, guys?
Till infinity.
Yes.
After it is decreasing, so it will vary till infinity.
Yeah. So at infinity, this will become 1 by infinity square, which is 1 by infinity. So 1 by infinity is how much? 0. So this will approach to 0 at infinity, right? So this is asymptotic to this r. So this will approach to 0, right? This will decrease and this will approach to 0 at infinity, right?
Yes.
So is that clear now, Tariq? Yes, Tariq, clear or any doubt? Yes, Tariq, are you there? Yeah. Yes, Tariq, are you saying something? Because we cannot hear you. So Chavez
Can you hear
and
me now?
yes. So
Yes, it's clear now.
oh, okay. Yes. So whenever in the graph you have, if you face some doubt, so just pick up some values. Just pick up some values, then you would be able to easily understand that, okay, so how the graph will vary. Yeah, so you have this point decide whether you are inside or outside. So lesser than this point, you are inside, and after that, this point at this surface, you are outside. So you have two variations. Yes.
Your electric field is maximum at certain.
Yeah, at maximum, yeah, electric field is maximum at this surface. Yes, nice observation. Yes, sir, Chavez. Because up to this point, it was increasing, right? So this is a lower value, lower value, lower value. At this point, it has reached the maximum, and then it starts to decrease. So KQ by R square is the maximum value. Okay, so let's not let's not discuss this further, and let's move on to the next topic. So the next topic is the stay-radian angle. So I will just write that you guys know that what is radian angle, right? So if your angle
Solid.
make, yeah, stay-radian is this is the solid angle. I am just talking about the angle, right? So if this arc makes the length r, which is the radius of this circle, so this will be called 1 radian, right, guys?
Yes, sir.
And what is solid angle? So if you have a square which is whose area is r square, right? So if you have this square whose area is, let's say this is whose side is r, right? So this area is r square. So if the angle make this area, this r square area, so that angle is called the one solid angle or one stay-radian, STR. So you have, let's say you have this, how do I make that angle? So you have this conical shape. Understood? You have this conical shape, and this is making some angle. So this curved surface the whole curved surface, not only two rays. So whole surface is making some angle. And if that is making the area, which is the area of a square, r square, so that will be called one steradian. So is that understood? This is called omega.
Sir, it's making an area of r square, so its shape will be rectangular circle.
No, so it should be a circle. So this cone will make some patches, whatever is that, right? But the area is equal to r square. Area is equal to r square. That is the whole idea. So that area is equivalent to the area of a square whose side is equal to the side radius of this circle. Okay. So let's say that you have this. So let's say that this is the patch that it is making r square angle. So this would be called one steradian, right? The area should be whatever is the shape. Whatever is the shape, the area should be r square. The area of a square whose side is r. Is that clear, Travis? Yes. Yeah. So this is how we define one steradian. Okay. So let's accept these results that comes from the steradian. That one whole sphere make 4 pi. So 4 pi r square area will make 4 pi omega angle. So this is the steradian angle, 4 pi, right? So whole sphere will make a 4 pi steradian angle. Understood?
Yes.
And this result. So just remember, I will not derive this result, but let's say that you have a cone, and this is the angle that it is making. Let's say this is alpha. So this whole solid angle would be, this omega would be 2 pi 1 minus cos alpha. So this is the result that you need to remember. Okay, for this cone whose slant angle is this. This is the angle that it is making. Yes.
Sir, can you once again repeat from that 4 pi omega?
Yeah. So whole sphere, right? So the area that that steradian makes is r square, right? So for r square, the area is 1 steradian. For area r square, the angle is 1 steradian, right? So for one area, that would be 1 over r square. So for a whole sphere, right? What is the area of the whole sphere? 4 pi r square. So for 4 pi r square area, the steradian would be how much? This would be 4 pi. Is that clear?
Yes, the notes.
Okay. So this is the steradian that it makes for the whole sphere. And for the cone, the steradian angle or the solid angle is this 2 pi 1 minus cos alpha. So this you don't need to prove, this you remember. So just remember this result. We will do one question based on this. So yeah, we will just do one question, which is the application of this part. So did you guys note down this part? So yeah, okay. So this was just the understanding part, but just note down from here. So you will see that how this solid angle is related with this electric charge there. So did you guys note it down?
Yes, sir, noted.
Yeah. So just see the example of a torch. So flashlight of a torch makes some solid angle, right? Right, guys. So flashlight of a torch makes some solid angle. Okay, done, guys. Tarif and Faiza, any doubt do you have?
Yes, I need to get and you cancel and ask for it. Raising it for 5 hours and not.
Yeah. So this part,
Yes, sir.
yeah. So you see that the area that one steradian makes is how much? R square, right? So for R square area, the angle is one solid angle, right? So for one area, 1 meter square or 1 unit square area, the angle would be 1 over R square, right? Is that clear, Tari?
Sure, sir.
Yeah. So what is the area of the sphere? The total area of the surface area of the sphere is this 4 pi R square. So for 4 pi R square, this would be 4 pi R square divided by 4 R square. Oh, this is R square. So this is R square and this R square will cancel and you will get 4 pi. Oh, so did you, were you talking about this square part?
Yes, sir.
Ah, yeah. So that was some missing. Yeah, the square was missing. Yes, correct, correct. Okay, noted everybody. Yes, so now let us do one question, which is direct application of this part. So, but before that, you guys know that how do we calculate the electric flux? Electric flux. So let's say at the surface of a cube. So if I want to calculate the charge is placed in here, and if I want to calculate the electric flux at this surface, one surface. So you guys already know that for 6 surfaces, yeah, for 6 surfaces, it is Q by epsilon. So for one surface, it would be Q by 6 epsilon. This you guys already know, right?
Yes.
Yeah. So now we have a question that the charge is placed. So we have this cone, right? We have this cone and the charge is placed at the vertex of this cone. So now we have to find out that what would be the flux through this curved surface area. What would be that? So uh, flux through this curved surface area. Right? We know this result. We know this result, and we also know something. So I have only half an hour and I have to do cavity part also. So let me direct describe the answer. So for the whole sphere, the angle is how much? For 4 pi steradian, the flux is Q by epsilon. Is that correct, guys?
Yes, sir.
So for 1 pi, this would be q by 4 pi epsilon naught. And what is the angle in here? So this is theta, guys. So how much is this angle? Curved surface area is making how much angle? So that would be this angle, this solid angle, right, guys? Is that clear, guys?
Yes, sir.
Yes. So this would be simply 2 pi 1 minus cos, this is theta. So this would be q into 2 pi 1 minus cos theta divided by 4 pi epsilon. So 2 pi cancels, and this becomes 2. So this would be q, flux would be q 1 minus cos theta by 2 epsilon. So you guys can see that how this becomes so simple. Otherwise, we have to calculate all these E and A, right? And then we have this portion, curved portion, and then we have this portion. So that would be difficult to calculate. This in this way, this is very easy. Yeah. So yeah, you guys quickly note it down.
Sir,
Please.
can I explain once?
Yeah. So you see that for this case, for this surface, what we do? For this surface, what we do is that we make this charge in a closed surface. And we know that in the case of Gauss law, any surface that is closing some charge, any surface that is closing some charge, so the flux through a closed surface is always q by epsilon naught, right? So what we do is that this charge is at the vortex of this cone. So what we do is that we make a whole sphere, right? We make a whole sphere, and we know that for the whole sphere, the flux is q by epsilon naught, right? So for 4 pi, the flux is q by epsilon naught. So then what is the angle, or what is the area of what is the surface that this is making, right? So this is this angle. So then for this angle, we calculate. Yes, Chavez, what is happening with your microphone? Yes.
We are finding flex of sphere here in code.
Yeah. So the flux of the sphere, or the area of the sphere, so this correspond to the whole 4 pi r square area, right? And this correspond to the conical area. Is that correct, Chavez?
Yes, yes.
So yeah, so that is how the whole this 4 pi, this closes the surface. This 4 pi steer radian angle closes the whole surface. Now we have to find out what is this surface, right? So for this surface, this is this angle. Is that clear now, Chavez?
Yes, sir.
Okay, please note it down, and then we will do the question on cavities. So I have half an hour. Let me try to finish. Yeah, you guys quickly note it down. So whenever you guys are finished noting, please tell me. Then So today only this electric charge will be finished, and then I'll start this electrostatic potential. So in electrostatic potential, the main questions comes from the capacitors. So a combination of capacitors, and then you place some dielectric medium in between those. So those type of questions. Yeah, you guys quickly note it down, and then so, so whenever you guys are finished noting, please tell me. Done.
Yes.
Yes, Tarif and Faiza, done.
Yes, sir.
Okay, so now, okay, so the next type of question is comes from the cavity. And only the part which is in the syllabus is spherical cavity. Okay, so you have a sphere, right? And then you have, so this is gauged out. So this part is gauged out, right? And then you need to find out what is the electric field at some places. So the, yes, yes, did you say something, Chavez?
What is the meaning of gauged out?
Yeah, so gauged out meaning that some portion is taken out, right? So you have gone to the ice cream shop, right? So they have something, and from that they take out the ice cream, right?
Yes.
So yeah, that is called the gauged out. So yeah, so this portion is taken out, right? Okay, so this is the portion that contains the charge. And the question comes that, so this would be given. This is the center of the sphere, and this is the center of, so this is another sphere, and the distance between these sphere is A. Okay, and the radius of this small sphere is B. So don't get confused with the radius of this big sphere. This A is the distance between the centers. Always remember that this A is the distance between the centers. Okay, So the idea to solve this cavity is that we assume two kinds of charge density. So for a complete sphere, we assume that this has some charge density, which is rho. So this has a rho charge density. And for the smaller one, we assume that it has a charge density, which is minus rho. So if this combines together, right, so if this is combined together, so this part will have a zero charge density, right? So this is how we solve this problem. We consider that this is made up of two spheres, right? This is made up of two spheres. One is this rho and the other one is this minus rho. So both are filled, and this is also filled. But it has the opposite polarity. This is rho, this is minus rho. So is that part clear?
Yes.
Okay. Now let us understand what kind of question comes. So this is the idea. Just remember this idea. This is the main idea. And the question comes that you have a sphere. Let me draw a proper diagram. Okay. So you have a sphere.
Sir, here the thing which is gaused out is having minus rho density.
Yeah. So this is empty. This is empty, but we make this case as that. Let's assume that this is filled, and you have this minus rho charge density. So if we combine these two, this will become like this, right? This will behave like this. Is that clear?
Yes.
Yeah. So this is empty. There is no charge here. So how can we make this charge the same? So this is how the idea that we apply. So we assume that this is filled. We have two filled sphere. So this part is empty, right? This part is empty, but we assume that we have two full sphere. This is filled. This is also filled. But what we do is that we combine with this negative one. So this will negate the portion of this charge density. If we combine this, so this will negate this portion, right? And this will behave like this case. Is that clear?
Yes, sir.
Yeah. So the question comes that you have a sphere, and this part is taken out, right? And you want to calculate the electric field at this point. So what do we know? That this distance is given. You have given this distance, the distance between these spheres. So let's say this is A vector. Okay. And let's say that this distance is S vector. And this distance is R vector. Understood. We want to calculate the electric field at this point. Inside the smaller surface sphere. Is that part clear?
Sir.
Yeah. So the charge density is rho, and this charge density is minus rho. So you guys tell me that. Let me draw this diagram here. So you have this vector. This is A, this is S, and this is R. So from triangle's law, what would be equal to what? Yes. Yes, if we apply the triangle's law, so what would be equal to what? we are going in this way and this way, and then we are going this way. So from the triangles, yeah, from the triangles law, R would be S plus A. Is that correct, guys? So my S vector would be how much? This would be simply R minus A. Is this part clear, guys? Yes.
Yes.
Yeah. So let me draw the corresponding diagram. So I have, I can write this as this one plus the smaller one. So the smaller one has, this is the center, and this is our distance. And for the smaller one, so this has a rho, charge density. The smaller one has this radius and this s distance. And this has minus rho. So you guys tell me that, so let's say that this is one region, this is one region, this is a second region. Okay. So this is a filled, this is filled sphere. So inside the sphere, what is the electric field? Who remembers? Inside the sphere, what is the, yeah. Let's say this is this is E1. This was the second region that I wrote, right? This is the second region. So let's say that this is the second region, and this is the first region. Okay, so E second would be how much? Who's going to tell me? This is inside, so E second would be how much?
CQ R by RQ.
Inside. So inside,
You are by
yeah, rho R
KQ,
by.
KQ smaller by RQ.
So you guys have forgotten. So yeah, just remember. So I was telling you guys, yeah, I just told you guys to remember this point,
Okay.
right? So this is rho R by 3 epsilon. Correct, guys? So in the second region, this would be rho R by 3 epsilon naught. And what would be E1? Yes. What would be E1? The distance is S. So minus rho S by 3 epsilon naught. Is this part clear, guys? Is this part clear? Yes, just see from here. So this is inside S distance, and this is R distance. And we are calculating the electric field at this point. So this will due to this first charge distribution and this second charge distribution. And both are inside. So this would be the final. And E net would be how much? E net would be E first plus E second. So this would be minus of rho S by 3 epsilon naught and plus of rho R by epsilon. And you guys have already seen that what is S. So S is R minus A. So minus of S would be how much? A minus R. Is that clear, guys? Yes. Okay, so let me just directly write the result. So this would be rho A minus R by 3 epsilon naught plus rho R by 3 epsilon naught. So this is rho A by 3 epsilon naught minus rho R by 3 epsilon naught plus rho R by 3 epsilon. So this cancels and we have E equals to rho A by 3 epsilon naught. So just to remember, guys, that whenever you have a cavity and you want to calculate the electric field inside this point, okay, so this will depend only upon the distance between the centers. So this will be only EA by rho A by 3 epsilon. Is that clear, guys? Yes. Is this clear? Yeah. So you guys, I quickly note it down. The idea is that we just make two spheres, two filled spheres to represent this scenario. Yeah, you guys quickly note it down and then we will do one question. Okay, I have 12 minutes, so yeah, one question is done. Let me. Yeah, should I scroll down the screen, guys? So Faiza and Tarif, do you guys have any doubt?
Really.
Okay. Yeah, should I scroll down the screen, guys?
Yes, sir.
Then one
Done.
can be cancel row and create
Yes, Tarif.
create one.
Why did I write rho r by 3 epsilon naught?
Yes, sir. So why can't we cancel? No, sir.
Yeah, yeah. Your voice is able to
Sir,
understand.
why
Your
didn't
voice
you
is breaking up. Right.
cancel?
Yeah. Why didn't I cancel which? So S and R are different. Different
Did you cancel row?
row. Yeah. So row is multiplied with R and S, right?
So can you hear me now?
Can we? Can we? What? You have some network issues. So can yeah, Chavez, can you tell me what Raif is saying? Wait, do I have that network issue? Yes, yes, Tariq, please ask. I didn't understand what you were asking. Maybe there's some
Sorry,
network.
sir, my Wi-Fi is a bit laggy right now.
Yeah, so yeah, now it is good. So can you ask the question again?
Oh. So why can't we cancel row and 3 epsilon 0?
Rho and 3 epsilon naught. So rho and 3 epsilon naught, how can we cancel this? Rho and 3 epsilon naught. Why this should be cancelled? Oh, this one.
Yes, sir.
So this is rho r by 3 epsilon naught, right? And this is rho r by 3 epsilon naught, right? But this is negative and this is positive. Is that clear? So I have.
No, sir, I'm talking about
Yeah.
the
So this is
one, yeah, minus row S. So,
minus rho s by 3 epsilon naught.
yes, sir. I didn't cancel the row and minus the epsilon.
You see that this is multiplied with different numbers. So let's say that this is minus 3 into let's say this is 4, and let's say this is plus 3 into let's say 2, right? So this 3 and this 3 cannot be cancelled. This is multiplied with this s and this r, right, Tariq? So we have to take the common if we want to
Yes, sir.
solve. So this would be, let's say, minus 3, and this would be 4 minus 2. So this would be minus 3 into 2, minus 6. So we cannot cancel this, right? Yeah. So this is the idea. We just put the value of s. What is s? Because this rho by 3 epsilon naught is multiplied. Is that understood, Tari?
Yes, sir.
Okay. So just remember this, guys, that whenever they ask you that what is the electric field inside this small sphere, so that will be related only with this distance between the centers. So the electric field would be simply rho a by 3 epsilon, whatever is the distance. Okay. This was the first question, and I don't have the time to calculate the electric field at this region. So what is the electric field at this region? You guys try. This is A, but not, let me not write this here. So the second part of this cavity is that you have this cavity, and they want us to calculate the electric field at this region. So this is A vector, this is S vector, and this is my R vector. So what would be the electric field at this point, this P point? So you guys think about that, but let me do the one different question. Okay, so the question, this question came in the JEE exam, and you have this figure. So you have this sphere, and the cavity is just, this is the cavity. So the total, this is at the center. Okay, the radius of this sphere is r, right? And this is r by 2. So this is r by 2. And they want us to calculate, we have 2 points, A, and you have the second point, B. So they want, yeah, who left? Okay, Tariq got disconnected. So they want us to calculate what is EA by EB and mod of that. So this is what. Is that, and is this question clear to you guys?
Yes.
Yeah. So we have, again, we have two regions. This is first, this is second. Okay. So let us calculate the electric field due to this first region at point A. So at point A, this would be how much? This would be rho, and this is R by 2 by 3 epsilon naught, right? And this should be negative sign. So this is minus rho R by 6 epsilon naught. So is this clear, Faiza and yeah, Tarif also. Okay. So is this clear, guys? Why? Due to first region at a point, this would be minus rho R by 2, 3 epsilon naught. Is this clear, guys?
Yes.
Yeah. So this is, and what would be the electric field at this point due to this second region? What would be that? Yes. So you guys, this is inside this sphere, and this is at this, yeah, this is at the center. So R is how much?
Cavity.
Yes, yes, Chavez, what did you say? Yeah. So R is how much, guys? Remember that E varies as R in inside the sphere. This R is how much at the center? So, so this is what we call R, right? So at the center, R would be how much?
Zero.
Right. So electric field would be how much? 0. Is that understood, guys? Okay, so I guess that, oh, yeah, is that understood, guys?
Yes, sir.
So EA would be how much? EA would be simply E1A plus E second A. So this would be minus rho R by 6 epsilon naught by, and then plus 0. So EA is simply minus rho R, not small, but capital R by 6 epsilon. Understood, guys?
Yes.
Yes. Okay, now we need to calculate the electric field at B. So for this we need to calculate E1B and E2B. Understood, guys? Is that clear, guys?
Yes.
Yes.
So you guys tell me that due to one region, this sphere is there. right? And we are calculating outside this sphere, right? We are calculating outside this sphere. So that would be how much?
Rho r by 2.
Rho r by 2 out. So that would be simply KQ by this is how much? So this is R by 2 and this is R. So 3R by 2 whole square. Is that clear, guys?
Yes.
Yes, is this clear? And you guys tell me that what would be this charge. So what would be the whole charge? The whole charge of this second region. What would be that? What would be that? So we are calculating the electric field at this point, and we know that E outside is E outside. Sorry about that. So E outside is yeah. E outside is simply KQ by whatever is the distance. So this is R by 2 and this is R. So 3R by 2. And we need to find what is this total charge Q. So we know that rho is how much? Rho is Q by V. Is that correct, guys? Yes. So we can calculate this Q as a rho into volume. So rho is how much? 4 by 3 pi R by 2 Q. And this is volume, and rho is minus rho. So this would be how much? Minus K is 4 pi epsilon naught. This is 9 R by 2 whole square, right? And this is 4 by 3 pi and R by 2 whole cube. So this cube cancels this square, and this 4 pi cancels this 4 pi, and we have how much? So 9 and 3, 27 and 2. So 54. 54 epsilon naught minus rho r. Is this clear, guys?
Yes.
Okay, so this is E1B, and who's going to tell me what is E2B? What is E2B? So for this second region, this is at the sphere, at the surface. So that would be simply rho r by 3 epsilon naught. Is that correct, guys?
Yes.
Yeah. So EB would be how much? EB would be simply E2B plus E1B. So this would be simply rho r by 3 epsilon naught minus of rho r by 54 epsilon naught. So 54 3 LCM is 54 epsilon naught. This is 18, so 18 rho r minus rho r. So 17 rho r by 54 epsilon naught. So this is EB. And we need to calculate what? We need to calculate EA by EB. EA by EB. Right. So EA mod by EB. This would be how much? EA is how much? Rho r by 6 epsilon naught, I guess. Yeah, rho r by 6 epsilon naught. So this is rho r by 6 epsilon naught divided by 17 rho r by 54 epsilon naught. Epsilon naught cancel, rho r cancel. 54 goes in the numerator, 6 and 17. So 9 by 17. This was the question, guys. Any doubt in this question? Sorry, I took 5 minutes more because I wanted to complete this chapter. Yes, any doubt, guys? Yeah, your microphone is, okay. So you guys try this question in your home also. You just note down this problem and you guys think about this problem. And whenever you have doubt, guys, so in the next class, you can ask me. So you guys, please quickly note it down. Okay. Oh, who got disconnected? So Chavez got disconnected. You guys quickly note it down. So Tarif and Faiza, you try this question in your home. Okay. And if you face any doubt, any problems, so please ask me in the next class. Right. I will be happy to repeat this question for you guys. Okay.
Sure, sir.
Yeah, you guys quickly note it down, or you guys you can take the screenshot. And yeah, so sorry that I took 7 more minutes. So sorry about that, guys. So yeah, you guys can take the screenshot. So whenever you guys need me to scroll down, you guys tell. Yeah. So
Scroll down.
whenever you need me to scroll down this, yeah. Yes. Done, guys?
Yes, sir. If possible, can
Yeah, if possible. If
can you show
possible,
that I didn't take the screenshot?
yeah. If possible, can I take what?
Can you show the one more question for to take the screenshot?
Oh, the question that I gave.
Yeah, yes, sir.
Yeah, this was the question. Yeah, please try this question. Okay. And yeah, this was the question. Are you talking about this? Yes, Tayo.
Yes, sir. This one.
Ah. Yes, Faiza, did you completed that portion? So were you able to complete that portion? Did you note it down? I just scrolled up.